Okay, so today we're going to be looking at probability. So, what do we mean by probability? Let's look at this general statement. So this is how to calculate the probability of an event. Well, there we go. Of an event. Now say we're doing an experiment and we can have different results. So the number of favourable results or outcomes divided by the total number of possible results or outcomes. Now, the caveat for this is the total number of possible results must be equally likely. That's important. So if you roll a dice, there's equal probability that you roll a 1, or if you roll a 6 or a 2 or whatever. That dice is not weighted, it's not it's just an ordinary dice. There's not a greater probability of rolling one number than the other. That's what that means, equally likely. So probability is a number, so the probability of something is a number between 1 and 0 and 1. So if it's 0, it's impossible, there's no probability it will happen, and that is, if it's probability of 1, it's certain. Okay, so let us look at a very simple example to show how this works. So the numbers 1 to 10 are written on bits of paper. These are folded and put in a hat. What's the probability of a 6 at least 8 or 12? So at least 8 means a number below 8. So what's the probability of 6? So the probability is going to be the number of favourable outcomes, number favourable outcomes divided by number of possible outcomes. So if it's a 6, so for this one, probability, I'll write P of a 6. There's going to be 10 bits of paper, and only one of those is going to have a 6 on it. So there's only one favourable outcome out of 10 possible outcomes. So the probability is a 10th. That's it. So the probability of at least 8. So it'll be greater than 8. So the possibility of either an 8, a 9, or a 10. So there's 3 possible outcomes, and again there's 3 favourable outcomes. You can get an 8, a 9, or 10, and there's 10 possible outcomes. So it's 3/10. You can't simplify that. And the probability of getting a 12, well, there's no 12 written on any of the paper. There's a paper, so there's 0 ones with the 10 or with the 12 on it out of 10, which is 0. That's logical. This way of writing P and in brackets what you're looking for is the shorthand for writing, instead of writing probability. We do it like that. So when you conduct a probability experiment or trial, then a particular result A. So we've done an experiment or a trial. A result A must either happen or not happen. It must happen or not happen. So if you were to flip a coin, it's going to be heads or it's not going to be heads. So we say the P, the probability of A does happen, plus the probability of A not happening equals 1. And that leads us to a really useful principle. We can rearrange that. So the probability A does not happen must equal 1 minus the probability of A happening. So let's use it in an example. So just through that. The probability that it will snow on Christmas Day. So the probability of snow on Christmas is 0.15. Find the probability that it will not snow. So the probability of it not snowing on Christmas is 1 minus 0.15, which equals 0.85. Okay, not all probability problems lend themselves to theoretical approach. For example, if you throw a drawing pin in the air and want to know the probability of landing point up, there's no obvious theoretical method. So you need to calculate the experimental probability. Okay, so let's think of a drawing pin. So a drawing pin, so is thrown 20 times in the air. It lands point up 13 times and point down 7. Now the thing with the drawing pin is it's not like a coin. You know it's going, if you throw a coin in the air, there's a 50-50 chance of it landing heads up or heads down. But something like a drawing pin, you don't have that. It's not a 50-50 thing that's going to that you're going to get it landing either way up. So let's calculate the experimental probability. A single throw results in pin up. So we're going to do, I'm just going to do an arrow for up. So we know it landed pin up 13 times, and we did it 20 times, so that is the probability. We can't, because it's a fraction, if we could simplify it, we would. So 7 out of 20 of the throws are pinned down. Let's imagine if the pin is thrown 300 times, what's the estimate for pin down? So we would do 7/20ths of 300, which is, put it into the calculator, would be 105. Okay. A special care should be taken when finding probabilities from a two-way table. So let's think of this. So we're going to do a table of showing boys and the girls, and year 7, year 8, year 9 total. And this shows the total number of boys and girls in these classes within a school. And total again. Very rough and ready table. So boys, 72, 66, 70, 208, 48, 44, 60, 152, 120, 110, 130, 360. Find the probability that randomly chosen member of year 8 is a boy. So probability of year 8 boy. So let's think about this. So there's year 8. There's 66 boys in total in year 8. But how many children are there in total? There's 110. So we're just thinking about year 8. So we've got to find the total we use is the total for year 8. Now we can simplify that down as 3/5. So what's the probability? Find the probability that a randomly chosen boy, is a member of year 8. So the probability of here for year 8, so we need to think that a randomly chosen boy is in year 8. So here's the ones the row for the boys in the school, and there's 208 boys, and we want to pick one of these boys from random, and what's the probability of being year 8? So there's 66 boys in year 8. Again, we can simplify this down to be 33 over 104. So the difference between them is the first question was, what was the probability that a child in year 8 was a boy? So we're looking at how many children were in year 8, it was 110, and there were 66 in boys, and that's where we get the 3/5. But the difference with the second one was, it was looking at all the boys in the 3 classes, and what was the probability that one of them would be in year 8. They're subtly different, and so those kind of questions you've got to be really careful with the wording. Find the probability of a randomly chosen member of the school as a boy in year 7. So a probability a child in the school is a year 8 boy. So again, year 8 boy. I actually should change that one just to be, I'll take that bit out there. Right, so year 8 boy. So we're doing, this is the whole school this time. So we need to think, how many children are in the school? There's 360. And again, 66 of the boys are year 8 boys. Simplifying that down, it'll be 11 over 60. So I hope that makes sense.